Python has several built-in data types like strings, lists, and dictionaries. These types are very convenient and they allow us to manipulate data as a unit. Okay, and these types all have methods to them. So when you have a list L and you call L.append, append is actually a method, even though we haven't called it that at this point in the class. All right, so these methods define behaviors on these data types, or things that you can do to the data that's encapsulated inside the type. All right, so each object has some data contained within it, and what we can do is defined by the methods that we have on that particular data type. Now, by itself, we could just use these built-in data types and create our own functions, and as we've seen, we can write some pretty interesting programs in Python. However, there's huge value in being able to define your own types. So object-oriented programming is centered around, well, objects. And what I can do is create new types for these objects. So if I define a new type, I can encapsulate some data inside that type. Then I can define a bunch of methods that define the behaviors that you can perform on objects of that type. If we do this, we have additional power and flexibility in our programs, and you'll see that it can make a lot of things much simpler. So let's dive right in and see what one of these new types actually looks like. I'm defining a new type that I'm going to call character here. So we're building some sort of game that has characters in it, and I want to encapsulate information about each character inside its own type. Now, in Python, as in pretty much every other object-oriented programming language, a type, when you define a new type, it's called a class. So in Python, to do that, we first use the keyword class. We say this is a class. Then we give the name that we want that class to have. In this case, it's character. And by convention in Python, class names always are capitalized, so you can see that I've capitalized it. Furthermore, like everything else in Python, we've got a colon at the end, so don't forget the colon. All right, now, after we've defined the class, we then can define a sequence of methods. And as I said, these are the behaviors that objects of this type will actually have. You'll notice that there are two interesting looking method names here. Init and stir. And these methods look just like functions. The only reason that I'm not calling them functions is that they're defined inside the context of a class. So they can only operate on objects of this type character. They can't be called directly in any other way. All right, now, the first special one is init. Underbar, underbar, init, underbar, underbar. This is called an initializer. This is how we initialize objects of this type. Right? And it takes, this particular initializer takes 3 arguments: self, name, and initial health. Now self is special, and I'm going to explain that in a second, so let's ignore that. The 2 actual arguments that I'm sending in to create new objects of this type are name and initial health. Right? Now, I use that self variable. That self variable is actually a reference to the new object. And by convention in Python, it's called self, although you're not required to call it self. You should call it self, okay? All right. What I do now is I'm going to create some fields inside of the self object. And a field is referenced with this dot notation. So self.name says the field name inside the object self. And I'm going to assign that the value of name. So this name here corresponds to the argument name up here. This name here is a field inside of the object self. I'm also going to then create a field health and have its initial value be the initial health parameter that was passed to the constructor. And finally, I'm going to define another field, inventory, and I'm just going to initialize that one to an empty list. Right? So when I create something of type character, I pass it a name and initial health. The self parameter actually gets sent in by magic. I'll discuss that a little bit more in a second. All right? And then I've initialized all the fields. Notice that I don't return anything. This init method is creating this new object self here, and it doesn't need to return anything. Right? Here's another special method, underbar, underbar, stir, underbar, underbar. Okay, this takes one argument, and that argument is self. And this one you never call directly either. You don't call these underbar, underbar methods get called behind your back by Python, and I'll show you code that uses it and actually gets them called. And in this case, when you call the stir method, so if you say stir of an object that is of type character, it will actually call this underbar, underbar, stir method for you, and it'll pass the actual object as self. And you can see that I'm building up a string s here. I'm creating a nice printout of the information about the character, and then I return that string. So the stir method should create a string and return it on all classes that you define. Now I've got two additional methods, which I'm going to call these behaviors that I've been talking about, right? My character can grab things, and my character can tell you what its health is. Okay, and those are the only two behaviors. Now you might add a bunch of other behaviors if you're really building a game. You might have a drop behavior, you might have an eat behavior, right? And eat increases your health, drop something out of your inventory, and so on, right? Grab takes this self parameter, just like all methods, and then it takes an item. This is the item that I'm going to grab, and all I do is I take the inventory field here, self.inventory, and I call a method on that. That's actually a list, which is basically another defined type in Python. It just happens to be a built-in type, right? That's already defined for us. I call .append here. That's the method on the list type, and I pass the item object. Okay. getHealth is even simpler. Right? All it does is return the self.health field. Okay. So here I have now defined my class character. Now I want to point out that I haven't talked about how I would use this class. And this is one of the beauties of object-oriented programming. I can define this class without worrying about how other people are going to use it. I know that the only way that they can use it is by calling these methods that I've created. So I've defined an interface, and I know that you will obey the interface, so I don't have to worry about it. I know that you're not going to sneak in and decrement my health by 100 behind my back. Right? I've given you no way to decrease the health with this character, therefore my health will always be at initial health. Okay, now that's silly in practice, but if I want to allow you to manipulate the health of the character, I add methods that do so. Now I don't have to know anything about how you use it. I know that you'll use it the way that I intended it. Right? Now I folded up this example here. Okay, I want to unfold it. This is the opposite side. This is using this class character. So let's fold that up. Okay, I don't care how it's defined. Well, actually, let's just fold the methods up. Okay. I don't care how the methods are implemented when I use the abstraction. Okay. When I use lists, I don't have to go and look at the implementation inside of Python of how append works. I just have to understand that there is an append method. Similarly, I just have to understand that characters have grab methods. I don't have to understand how it works in order to use it. All right. So here's how I actually create an object of my new type. The class name becomes the constructor. So when I want to create a new character, I call character as if it were a function, and then I pass the argument's name and initial health. You'll see I don't pass self. All right, that gets handled behind my back. And that the init function, even though it didn't actually return anything, returns the new object that was created. Okay. Here's how I call stir. If I use stir of me, it will behind my back call underbar underbar stir underbar underbar, and it'll pass the object me as self. Right now I can grab a pencil and paper. Now this has got to be the most boring game you've ever seen if you're grabbing pencils and paper, but okay. Right, I can print the thing again. Similarly, I can call getHealth. Right, and it will print that in my print statement. Right, so you can see here. I created my character Bob with 20 health. I print out the string representation of him, and you can see here's my string representation, okay, of my character Bob. Right? Now I grab some items. I print it out again. You can see that my inventory has changed from being an empty list to being a list with my exciting pencil and paper items. You can also see that I can print out my health, and you can see that my health is 20. So that's it. That's really the basics of defining and using your own classes to create types in Python. Now obviously, doing this for real to build something that's more interesting than our simplistic character class adds a little bit of complexity, but really you just have to define these methods to create an interface that can be implemented by you as you build the class and used by you when you use the class. All right? So we'll look at some more complicated examples throughout the week.